In this video we are going to see how to design and simulate the inverter in cadence. First of all, open your terminal, just type virtuoso and to open it. Wait, I will say a thing for you. The purpose you are adding an AND here will bypass the terminal for you. For example, if my virtuoso is here and I also access the terminal like this. If I will show you without AND. Okay. Now I just closed the virtuoso. Okay, and I am just now typing virtuoso, and without AND symbol I am entering. You see my cadence is opened, but in here I can't type, my terminal is locked. So why I am saying you to add virtuoso and okay, I need to use AND because I use the terminal in between. Just exiting virtuoso. Okay, virtuoso. Okay, just get into the virtuoso. I'm using a 50 nanometer PDK. I think you all use an academic of 45 nanometer PDK, 90 nanometer, 180 nanometer PDKs. That PDKs, that are GPDKs. We can use the GPDKs only for educational purpose, and this is 15 nanometer PDK. This PDK is used in industry to fabricate. You can use your 45 nanometer or 90 180 nanometer GPDK. I am using PDK. Everything has the same steps. Okay, now you want to create your folder to store your projects. Just click new, file, new, and in that click on the library. It will show like this. Give any name to your library. I am giving VLSI, and just click OK. Then technology file, you need to select the attached to an existing technology library and press OK. Our technology library is 15 nanometer PDK. For you it may be a 45 nanometer or 90 or 180 nanometer GPDK. Click on that and press OK. You see here a VLSI new folder will be created. Okay, now we will begin. Just press file. Ensure that you need to click on this VLSI file, new, cell view. Okay, in the library of VLSI, next you are creating a cells and your cell name is inverter. I am just typing INV. You can give what name you can affordable of. Also ensure that the type is schematic, because first you need to draw the schematic of inverter, and just press OK. Then you can see a window like this. This is an editing window for a schematic. I need to say another thing. This is called CAW window of cadence. You can see everything here. If any error occur or any information warning, everything will be shown in this area. This is named CAW. It stands for cadence interface window. You can use this to verify you are doing correct or any warning is arising like that. Now no need to check. I will say when you need to check it. Okay, this is the schematic drawing window, and you see there are many options. We can go one by one. Here you see a create instance, which is like a transistor symbol. Just click on it and it's asking your library. My library is 50 nanometer PDK, and you can choose 45, 90 or 180 nanometer GPDK. After, you need to select a cell. I am selecting PMOS. The view type is symbol. There are many types, but now only you need to use the symbol. Ensure that. and my model name is not PMOS, it's an PFIT. uh, Afterwards I will show you why I changed the name to PMOS to PFIT. There is some reason, I will explain it later. And just click hide. You will see it's comes and attached to your cursor. Just scroll in to zoom and scroll out to zoom out. Just do a click, it will places. Next just press escape, it will gone. Okay, now this is your PMOS. Now you need to add NMOS, same that, and you need to search for NMOS. Here is the NMOS, and here also this is not NMOS, this is an NFIT. Okay, just hide. And this is the NFIT I am just placing here. You can see the symbol here, this is PMOS symbol and this is an NMOS symbol. Now you need to give the connections. You see here is an create narrow wire. Near this there is an create wide wire. You see this is a narrow wire, and this is an wide wire. See, the wide wire is much more bigger than narrow wire. The narrow wire is used basically in this full tutorial we are going to use this narrow wire only. The purpose of this wide wire is only for bus control. If you are designing a 8-bit counter or some protocols in 8-bit or 4-bit something, you can use this. We can split this single wire into much more bits we need. So now we didn't want it. We just if you don't want this, you need to select and delete the backspace or delete key in the keyboard. Okay, the hotkey for using a wire is W. You can see now your cursor is looking like a cursor symbol. If I press W, it will changes to something and something, but it's wire. If you go near to this will show like this, like attaching to there. Okay, now I am connecting the gate of the PMOS to the gate of NMOS. Okay, now the drain to drain, and the source of NMOS is gone to the ground, and the source of PMOS is gone to the VDD, which is an power supply, DC voltage, something similar. And I need to say here, basically a transistor consists of 4 terminal. This is source, and this is gate, and this is drain. This is the body. You can call it like body, bulk, substrate. It has some many names. I am basically use it as a body terminal. You can use substrate or something what you affordable of. It's an easy concept. For PMOS, you need to connect the body to the power, which means VDD. For NMOS, you need to connect the body to the ground. This is common for every circuit, every transistor. If transistor is PMOS, you need to connect to VDD. If it is an NMOS, you need to connect to ground. Okay, now take an wire. We are taking the output from the drain. This is an input. We are giving the input in both gates. Okay, and here is a create pin. Just click on it. You need to give input names. I'm just VDD, GND. For input IN. Okay, you see the direction, this all are inputs. Just hide. You see this is an pin like structure. Press R to rotate it. Keep here VDD and ground, and this is the input. Now we need to keep the output. Again create pin out, but this time you need to change the direction because this is not an input, this is an output. Then just click hide and press it on output. Okay, now it's completed. You just press check and save. Okay, now you can check the CAW window. Okay, it's no problem. VLSI inverter Schematic is saved successfully. If something error occurs, it will show here what error, what is the problem there. Okay, after saving, just we need to make a symbol for this circuit. Just go create cell view from cell view. Okay, you see to view name symbol. from this is an schematic and we changing the schematic to symbol. Just click OK. Now you need to declare the pin, where which pin need to place it where. Basically the ground and VDD is not placed left side. In all the circuit, VDD is placed at top, the GND is placed down. This is a simple concept, not any rules. You can also place VDD up, down, left, right, anywhere it will work, but this will increase your readability. Then simply press OK. Okay, this is a symbol, and this is not look like an inverter. You need to change the symbol. Press this X mark, which will delete, and your cursor will change nearby an X. Just click on everywhere. This. You can delete this part name, but don't delete this instance name, because the instance name is important. Just double click this and you can edit this. I'm just giving an INV as a name for this inverter. Okay. Make everything, the symbol must be look good, because if the circuit is more and more, you need to maintain your readability. I'll click that line and just draw an inverter. Here is a circle. Okay. Okay, fine. Now just select this and make it attached, and this here, this here, and input here. Place the inverter inside. Okay, now we need to again add on boundary. For that, create selection box. Click automatic. The purpose of this is called as PR boundary. This red color line is called PR boundary. Why we are using this means, if you are placing too many circuits, you don't need to attach, or if you're placing one circuit, that circuit should be outside this red line, because if your circuit is another circuit placed inside this red line, it will show an error. Okay, then simply click check and save. Now okay, again check the CAW window. Okay, symbol saved, no problem, it's fine. Okay, just we are closing it. Close. See, this is your inverter cell. In inverter cell you have an schematic and symbol. Now you need to verify is this correct or not. For that, click on this file, new, cell view. Click inverter. Now we need to test this inverter, so I am giving inverter underscore test. Okay, enter. Again it will open. You can press the create instance. In this time you don't go for this PDK, which means your 45 nanometer or 90 nanometer GPDK. Go to your folder. We named as folder as VLSI. Go inside that. In that cell you see an inverter cell. Now we created, and there is a symbol. Okay, it's you see your symbol here, and just click hide. Your symbol will come here. Just press it and click escape. Now we need to give the supplies to this. For this, add instance. Now go to your analog library. In this analog library you have your all supply voltages, sine, pulse, VDD, VSS, ground, everything inside it. Now we don't need more like V sine, just we are using a simple, so just type VDC. Yeah, hide. You see this is an DC supply. Just press R to rotate, keep here, escape, again here, analog library. Now we need to take pulse, PULC, V pulse. Okay, now pulse is your input, and we need to keep the ground, GND simple, and press GND, hide, and make the ground. Okay, now just wire them all. This is input, and ground is connected to ground. and this negative is connected to ground, and this VDD is connected to positive of terminal of DC supply, and this minus is connecting to this ground. And you see we need something to connect here. For that, here is an create pin. Just click on it, just type out or v out something what you want. The direction should be output, and press hide, place it, press W, connect this. Now you need to give the power supply for this. Just click and press Q. Q means it will show your properties. You see here DC voltage. I am giving a 0.5 volt as a DC voltage, which is 500 millivolt. If you want, you can go for 1.5, 2, 3, something whatever you need. I am basically use 0.5 volt and click OK. Now we need to give the sign pulse input. Press Q, and you see two voltages. My first voltage is 0 volt and my second voltage is 0.5. The period I am using here is 20 nanosecond. I don't need delay. The rise time is 0.1 nano. The fall time is 0.1 nano. And the pulse width is 10 nano. Okay, that's fine. You can modify whatever you need. Then just click save. Launch ADLE. If something asks like this, just press session. Okay, just go to the setup and model library. You need to give your library. Just click like this and go here. You need to select your library. My library is inside one other thing. I am using a Synopsys HSpace for simulation, but you will use a Spectre, because I think in India mostly every flow is done in cadence, but in Taiwan they use Synopsys HSpace for simulation and Menta Graphics Calibri for layout. In India, academics, they don't use Synopsys, they use only cadence. So you don't want to go for HSpace, you can go for Spectre. Even in Spectre there are some models. For me, fed.inc is the model. Just I'm opening and simply pressing apply. Right, I need to show something you. Okay, I think this video is too lengthy. I will show you in later videos. Just click OK, setup, and you don't change. This is normally Spectre. You are using Spectre. I am using HSpace, so I'm changing this. You don't want to change this. Oh, okay. Now you need to insert your values. Click output to be plotted. Select on design. Just click this and click this. You see the wire color will changes, and that will named here out net1. You can name this as an input. Use this. Here is a symbol called ABC. Just press and click on here and give a name. I will show you in next video. Okay, just you need to give some analysis. I'm using transient. Start time is 0, stop is 50 nanosecond, step is 0.1 nano. Just press OK and simply press this green symbol, which is run button. You see my HSpace is running here. What? Job aborted. Why? Let's save. Run. Aborted. Why? Setup model library. Oh, I forgot to select the model library. Okay, apply. Okay, I am just clicking this run button. Okay, you will see a waveform here. Width medium, style solid. Okay, you can see this is our input, this is our output. If the input is high 1, the output is 0, low. If the input is low, the output should be high. It's okay, this is fine. This is an inverter's character. We can derive it. I'm not taking the layout now. Because the video is too lengthy, I will take the layout and analyzation, because this is a Calibri which is different from using in India, so I am using a next video. Okay, we will meet continue in next video.